Hello guys, welcome back again. My name is Amit and it's go time. So it's 1st of January 2025. So it's the beginning of a new year. So first of all, happy new year to everyone. May this year bring the best moments of your life and may you achieve great success in this year. And in continuation with the DSA series, we are back again with the C++ STL part 2. So without wasting any time, let's dive into it. So in this video, we'll cover stacks, queues, priority queues, and list in C++ STL. And so anyone who is new to this video, who is seeing this video for the first time, you can go and check out the first part of this video, and that link would be in the top right corner. And let's start with the part two. So first of all, we'll be covering stacks. So the first data structure that we are going to cover in this part is stacks. So most of you know about stacks. What are stacks? It uses basically the LIFO technique. LIFO means last in first out. So stack is basically data structure that maintain a stack type of manner. We know what is a stack. Stack means things kept one above another, right? Like a stack of books. So if you want a book that is at the bottom, then you need to remove all the books that are present at the top. So basically that intuition, that idea comes from these real life applications. Stack means a stack of books. That's why when you want an element, a book from from bottom, then you need to remove the upper books, right? And that is same what happens in stacks in C++. So you can push an element, okay, and it goes down to the bottom, and you keep on stacking up the elements. And if you want an element, a particular element, then you need to remove all the elements that are after that are top of it, right? So whatever comes the last is going to be first popped out, right? That's why it said last and first out. Whichever book you keep at the top of the stack is basically the last book that you keep, right? And that book is actually the first one that is removed from the stack. That's why last in, first out. Okay, so in C++ stacks basically work in the same manner. You can push any type of data structure. You can push float, double, string, integer. Okay, and you can also push derived data structures like pairs, maps, vectors. You can push anything. As I said, now in C++ these data structures are very dynamic. You can use any combination of data structures to push into any other data structure, right? In a similar way, stacks also provide a very dynamic applicability, right? Flexibility. And the functions that are used in the stacks are push. So push is basically for pushing elements, okay? And so pushing basically means that you push an element on the top of the stack. Then you have a pop element. Pop basically removes the top element from the stack, okay? Then we have the top function. Top function basically returns the top element of the stack, whatever stack you are having, whatever is the current element on the top of the stack, basically it returns that element. Size tells you whatever is the size of the stack, and empty, it tells you if the stack is empty or not. So remember, all these data structures are dynamic. Okay, their size can change, can vary, it can decrease or increase. So that's why there is no fixation upon the size of the data structure. Okay, and this basically covers up the functions that are used in stacks. The implementation we'll be seeing afterwards, okay, when we cover all the data structures. And a very brief example of stacks would be recursion calls are a great example of stacks usage. If you have heard about recursion, then you might be knowing how recursion works. Recursion is basically a stack of function calls. What happens, a function calls itself with some other parameters, with some changed parameters, right? And that is how function calls are stacked up one above another, right? When you let's say, we can take an example of DFS call. When you put a DFS call, you start from a root, then you take some neighbor, some neighbor node, and then you go into its depth, right? And in this way you move up to the stack, right? And in this way function calls are stacked up one above another. Okay, whenever something, a function call is evaluated, then it is popped out from the stack, and then we move on to the previous function call. And that is how a function, a recursion stack is maintained. You might have heard about recursion stack overflow. It is the same thing. Function calls are stacked one above another. Whenever it exceeds the memory limit, it gives you stack overflow, right? And you can declare a stack in this way: stack data type and the name of the stack that you want to give it. Okay, in this way you basically declare a stack in C++. Then we move on to the next data structure that we are going to discuss, that are queues. Queues are also, a very important data structure. They use FIFO or FCFS pattern. Okay, so what is FIFO? FIFO basically means first and first out. It's basically like, मैं पहले आया तो मुझे पहले मिलेगा, right? That kind of a, thought process. And FCFS basically means the same thing, first come, first serve. जो पहले आया उसको पहले मिलेगा. So in short, we can say what happens in queue is whatever element is pushed first, it also gets to be popped out first. Okay, you can take an example of getting tickets, or in a movie line. Okay, let's say you are in a line for getting movie tickets. So that basically is an example of queue. So whosoever person is at the front of the queue, at the front of the line, will get the ticket first, and whosoever in the last will get the ticket in the at last, right? And that is how queue works. Whosoever comes first will be served first. Whosoever comes first in will be the first person to be get out, right? And that is how queues work. Okay, so you can see how queues work. So in queues, what happens? Whosoever is at the front will be popped out first, and whosoever at the last, it will be popped in first. Okay, that is how this thing works, right? And this is basically a declaration of queues. In C++, you write queue and you give the data type, and then you give the name. And the functions used are push. So push is basically for pushing the element at the end of the queue. So basically कोई भी नया इंसान अगर लाइन में आता है तो वो पीछे जाता है, राइट? कोई बीच से लाइन काट नहीं सकता. Whenever a person comes up, he has to stand at the end of the line, right? And that is how what happens in queue. Any element that comes in has to be pushed at the last. And what is pop? Pop basically means removing an element. Any element that is in the queue, whichever element is at the front will be popped first. जो भी आगे होगा वो पहला इंसान जाएगा, वो एलिमेंट पहले हटेगा, right? What then we have a front function. So front function basically returns whichever element is at the front. जो भी जैसे हमारे stack में top था वैसे queue में front होता है. Then we have size and empty function. जैसे कि हम देख सकते हैं, these are very common in almost all of the data structures, right? And this is how basically queues work. And queues come in very handy in a lot of problems, right? Stacks are very analogous with DFS calls. Okay, whenever we are going to study about depth first search, we'll see how stacks are basically very near to the implementation how DFS is implemented. And when we implement BFS, depth first search, we generally use queue. So we'll see how these things work. Okay, what their significance and importance at that point of time. Okay, and this is basically a very small example. Standing in a line, you need to buy a movie ticket. You stand in a line, right? And queue in actual English also means a line, right? It means people standing in a line. Okay, and we cover queue now, and then we move on to DQs. So DQs are also very important and a very interesting type of data structure. It is basically an extension of a normal queue. Okay, a queue basically provides you insertion at the end and popping from the front. But DQs are known as double-ended queues, and double-ended queues basically, as we said, they are same as normal queues, but they have a major advantage that elements can be pushed, popped, and retrieved from both the ends. You can push an element at the front, and you can also pop from the front. You can also put an element at the end, and you can also pop from the end. And you can also get the front element, and you can also get the back element. So what do we have? It kind of follows this kind of a diagram. You can see in this diagram that we can push and pop out, we can push and pop out from both the directions, right? And that is why we have specific functions in this. We have pop front. Pop front basically removes an element from the front. Then we have pop back. Pop back removes an element from the end. Then we have pushback. Pushback is for inserting element at the end. Okay. Then we have push front for inserting element at the front. Okay. So we can see that these two functions, this pop back and push front, these two functions are in addition to the normal queue. ये तो हमारा normal queue में भी होता था कि भाई फ्रंट से पॉप होना और बैक से पुश होना, ये तो normal queue में होता था. जब आप ये दो फंक्शन देख रहे हो, these are new additions to the DQs, right? And then we have size and we have empty. Empty tells you if a data structure is empty. Then we have front and back. Front basically tells you the front element and back tells you the back element. This is basically the total number of functions that you use in a DQ. And DQ is also a very it finds application a lot of questions when you will be handling questions on monotonic stack. Okay, then it might be possible then you will be coming around this data structure and you'll be using it. Okay, and it has a lot of advantages. Okay, क्वेश्चंस में बहुत बार ऐसा होता है कि इट गिव्स यू एन एडवांटेज, इट गिव्स एन एज ओवर इंप्लीमेंटिंग सम एल्गोरिथम. ओके, इट ब्रिंग्स डाउन योर टाइम कॉम्प्लेक्सिटी. अब वो कैसे होती है, वो प्रॉब्लम स्पेसिफिक है एंड विल डिस्कस जब हम डीक्यूज के ऊपर क्वेश्चन लगाएंगे, राइट, इन फर्दर वीडियोस. ओके, डीक्यूज कम इन हैंडी इन अ लॉट ऑफ केसेस. वन एप्लीकेशन कैन बी 01 बीएफएस. ओके, 01 बीएफएस बेसिकली ब्रेथ फर्स्ट सर्च का एक टाइप होता है. इसमें एज वेट आइदर 0 होती है आइदर 1 होती है, एंड वील टॉक अबाउट इट इन अ बिट डिटेल व्हेन वी आर रीडिंग अबाउट ब्रेथ फर्स्ट सर्च. ओके, फिलहाल के लिए वी कैन से दैट डीक्यूज can be used for implementing 01 BFS. Okay, then we have DQ. So DQs are declared in this way: DQ and data type and name. Okay, and that covers DQs. Then we move to priority queues, and priority queues are one of the most important data structures among all of these. Okay, priority queues basically represent heaps. Okay, heap क्या होता है? Heap basically दो टाइप का होता है. There are two types of heaps: a max heap and a min heap. So we can see PQs are a very important data structure and it maintains a heap structure for storing data. हीप क्या होता है? बेसिकली एक ट्री फॉर्मेट का स्ट्रक्चर होता है, नॉट एक्जैक्टली ट्री बट एक ट्री फॉर्मेट में होता है. बट व्हाट एक्जैक्टली हाउ हीप मेंटेन थिंग्स? Heaps are majorly of two types: min heap and max heap. And okay, so how heaps work, how heaps are maintained, how the structure of a heap is maintained, how heap is implemented, how you build a heap, that all we'll cover when we'll be reading about heaps in further videos. When we'll cover heaps, stacks and queues together, then we'll be covering in detail how heaps work. From current point of view, you only need to know there are two types of heaps: max heap. In max heap, what happens? Top element is always the maximum. So max heap में क्या होता है? जो maximum element होता है वो हमेशा top में maintain रहता है. Whenever you remove an element, उसमें कुछ पीछे कुछ फंक्शंस होते हैं, कुछ प्रोसेस होता है, और उसके बाद अनदर द नेक्स्ट मैक्सिमम एलिमेंट comes at the top. So इस तरीके से चलता जाता है. In the min heap what happens? The minimum element is always at the top. जो कि हमेशा सबसे छोटा एलिमेंट होगा वो हमेशा टॉप पे रहेगा. जैसे आप कोई एलिमेंट रिमूव करोगे तुरंत फिर से एक प्रोसेस पीछे चलेगी बैकग्राउंड में, और उसके बाद whatever is the minimum element, next minimum element, that will come at the top. And that is how max and min heaps work. Then we have the declaration of max and min heaps. So max heap has a very simple declaration. आप देख सकते हो, you write priority queue and you write data type and you name that priority queue, right? And this is basically the implementation of priority max heap, right? There's a very simple implementation. The problem comes in when we have to implement a min heap. Min heap has actually a quite long declaration. इसमें काफी थोड़ा टाइम लगता है, थोड़ा लंबा declaration होता है. You write priority queue, then you specify the type, then you write vector of type, then you write greater of type. Okay, this greater of type is basically for specifying that minimum element has to come at the top. Okay, in C++ STL you can also write custom based priority queues. Okay, let's say कि आपको अपने priority queues में मैक्सिमम एलिमेंट को टॉप पे नहीं रखना है, या मिनिमम एलिमेंट को टॉप नहीं रखना है, या फिर कुछ और दिमाग में आइडिया है आपके, यू वांट टू यू वांट प्रायोरिटी इन अ डिफरेंट वे. ओके, सो प्रायोरिटी इज बेसिकली एज अ पर्सपेक्टिव थिंग. प्रायोरिटी किसी के सबके लिए अलग अलग हो सकती है. लेट से आपके क्वेश्चन लगा रहे हो उसमें प्रायोरिटी मैक्स और मिन नहीं है, कुछ और चीज है, यू कैन राइट अ कस्टम बेस्ड प्रायोरिटी फंक्शन. ओके, so what do? You create a struct and write a custom operator function, custom operator sorting function. Okay, not sorting exactly, but a custom operating priority function. Okay, and then you just specify that function name here. Instead of creator, you just write that function name, and your priority queue will arrange the elements according to that priority function. Okay, so that is also a very big advantage that you get in C++ STL, that you can use custom based priority queues. Okay, and then we have function stop. Top basically gives the top element at the priority queue. Then you have the size of the priority queue. Then you have push for pushing the elements. Then we have pop from for popping the top element. Okay, pop basically again pops the top element from the priority queue. Okay, it might seem that priority queue is a mix of queues and stack, but it is not. It is a very different data structure. It basically maintains a heap structure. Okay, so don't get confused by the function names. It is very different. Okay, and then we have empty. Empty basically returns if our data structure is empty or not. PQs are a great example of how priority reservations are done. So you know about flight bookings and you have dinner reservations, right? उसमें क्या होता है, अब priority के हिसाब से they arrange things, right? Even in ticket booking, you know that if a person gives better amount, then priority is different हो जाती है, right? So this priority reservations is a very great example of how priority queues work. And another great example is urgent task. When you schedule tasks in an urgent way, okay, which task is more urgent has to be given more priority, and that is how we implement things in operating systems. In operating systems, if you have heard about it, or you might cover in your your academic structure about operating systems, there's a thing known as MLF queues. MLF queues means multi-level feedback queues. So multi-level feedback queues basically use priority queues, okay, in multiple levels. Okay, whenever a process comes in, okay, then we see if that process can be converted within a timestamp, can be executed within that timestamp. If not, then it is sent down to the lower level priority queue. Okay, in this in this way, MLF queues arrange tasks in urgency manner. Okay, whichever task is more urgent will be given more priority. Okay, in that way, how in that way MLF queues work in OS. Okay, you might read about it further onwards in your course curriculum. Okay. Okay, that's not a problem. Let's move onward to the final data structure of this video. We have list. So a lot of people might be confused at what is list in in C++. In Python, it is very evident कि list क्या होती है, कि उनका बहुत ही सबसे basic data structures में आता है. But list in C++ is something that not a lot of people use. Okay, and list in C++ actually works very similar to DQs. Okay, डबल इंडेड क्यूज और लिस्ट जो होते हैं वो बहुत सिमिलर तरीके से काम करते हैं, पर उनका बैक एंड इंप्लीमेंटेशन बहुत डिफरेंट होता है. ओके, List in C++ are implemented as doubly linked list. Okay, we know about a linked list, right? Linked list हम आगे चल के पढ़ेंगे, but for current point of time, just remember this thing, that list in C++ are implemented in the form of doubly linked list. Okay, in the backend, right? And they're very similar in working to DQs. बहुत similar काम करते हैं, but traversal is slow. Okay, traversal part in list is very actually quite slow, but whenever you traverse to a position, the time of insertion, deletion, and retrieval is very fast. It's order one, it's constant time. Okay, so अपने अपने pros and cons होते हैं. And then we have again the same functions: push back, pop back, push front, pop front, back and front. So you can see almost all of these functions are very similar to DQs, right? सब कुछ similar है. Size है, insert है. Then we know about begin end. Begin end are basically for returning the beginning pointer and the ending pointer. So that is how basically list work. इसका implementation अभी हम देखेंगे. And then we have how we declare a list. Declaring a list is very easy. You write list, then you specify the data type, and then you write the name of the your list. Okay, and this is basically how a doubly linked list looks like. Okay, that for each node you have two pointers. One is a current next pointer, and you have a previous pointer. Okay, this basically is the next pointer ki kaun si next node hai, and this basically a previous pointer which tells you what was the previous node. Okay, that is how a doubly linked list looks like. Okay, so now we'll be moving onward towards the implementation part, how these things work. Okay, just let me. Okay, so now we'll start implementing all of these data structures and how do they work in actual implementation. Okay, so first of all, hash include bit slash stdc using namespace std, and then we declare the main function, and then we write return 0. Okay, now we'll start with stacks. Okay, stack. So I'll declare integer type stack and I'll name it st. Then let's say st dot push 2. Then write st dot push 3, st dot push 1. Okay, and now we'll just try to see how these things are arranged in a stack. So I'll write while not st dot empty cout st dot top. Okay, and since we know that these things are basically these are not iterative, right? We have to pop an element. Okay, we have to pop an element. So what we'll do, we'll just do st dot pop. Okay, this will remove the top element from the stack and we'll move on to the next top element in the stack. Okay, and let's try to see how these things work. Okay, so we can see that first we'll push 2, so then we push 3, then we pushed 1. So the order of the the traversal would be top element would be 1, then below it would be 3, and at the bottom would be 2, right? So let's try to run this piece of code. STL part, uh, what is SYL? STL part, not part. I write 2 here. Okay, it's getting compiled. A.exe. So yeah, we can see that 1 was at the top, then we had 3, then we had 2. So in this way, basically, we iterate over the stack. In this way, we push, in this way, we pop, and this is how we check if the stack is empty or not. We keep on pushing. Okay, we keep on popping, right? Okay, then we go on to queues. Okay, I'll just comment this piece of code out. You can go back and watch this thing again. Then we move to queues. Queues again, I will just use queue. You can also use a string. Okay, let me choose something different. Let's take character values. Okay, queue so this basically queue will store character type of data, right? Okay, so what we'll do, q dot push a, then we have q dot push c, then we have q dot push b. Okay, so now what I'll do, I'll just iterate over it again. While not q dot empty cout q dot front. Okay, so basically this gives you the front element. Okay, and q dot pop. So here we'll see, since these are in queue order, right? A came first, then C came, then B came. So that's why the traversal would also be A, C, and B. Okay. In stack we saw कि भाई जो आखिरी में आया वो पहले जा रहा है, right? It would look like 132. In this case, it would look like ACB. Okay. Let's just try to run it. So we can see A, C, and then B. In this way, basically queue is implemented and queue is used. You can use any data structure, any data type in here. Instead of character, you can take string or int or double or float or anything you want. Okay. So this was about queue. I'll just comment it out. Then we move on to what? Then we move on to DQs. Okay. So DQ is very important. I'll just write. Generally, I favor writing DQ. Like DQ, and then I write DQ. So it basically eases my thing. So दिमाग में रखने में easy पड़ जाता है. So I'll tell you how these things work. So DQ dot push front. So you can see there are two functions being hinted at: push back and push front. So push back will what it will do? It will push the element at the end. Push front will push the element at the front. Okay, let's do push back first. Push back I'll do 2, and then I'll do DQ dot push back 3. So currently, if you try to print the DQ, it will look like 2 and then 3. Okay. But now what I'll do, I'll push front. मैं क्या कर दूंगा? मैं front में push करा दूंगा. Front में I'll push 4 and I'll push DQ dot push front 1. Now what will happen? Instead of 2 and 3, now your DQ will look like 1 4 2 3 1 4 2 3. ओके, सो हमने पहले 2 और 3 को एंड में पुश कराया. उसके बाद क्या हुआ? इनिशियली वो ऐसा दिख रहा था 2 and 3. फिर हमने इसके फ्रंट में पुश कराया, सो इट बिकेम लाइक 1 and 4. ठीक है, सो योर DQ विल लुक लाइक समथिंग लाइक दिस. ओके, अब इसको करके देखते हैं. वाइल ओके, while not dq dot empty. Okay, we'll write dq. So you can write dq dot pop front, or you can write dq dot back. Okay, you can also at the same time we'll also try to write the front element. Okay, dq dot front. Okay, and then you can, it's your choice, you can either pop it from front or you can pop it from back depending upon whatever your question demands. So just for explanation, I'll just write pop back. Okay, you can also use pop front. Okay, so let's just try to run this piece of code. So yeah, we can see initially what happened. Your data structure looked like what? As I said, 1, 4, and then what? Then 2 and 3, right? So in this way, your DQ was arranged, right? So first of all, we have DQ dot back. So what is the last element? We have 3, right? And what is the first element? We have 1. So we can see 3 and 1. Then we pop it from the back, right? We remove the back element. So 3 will be removed. When 3 is removed, we are left with 1, 4, and 2. Again, back element is 2. Then we have front element as 1. So again 2 and 1, right? Then this 2 is removed. Then we have 1 and 4. For 1 and 4, we can see, the back element is 4, the front element is 1. Then we again remove 4. Then we are finally left with only single element 1. So back and front both are actually the same element, and then we remove it from the back, and now your DQ is empty. And this is how basically your DQ works. Okay. You can try out pop front and other things like DQ dot size. Dot size function is basically common in all of the data structures. You can go and implement it for anything. Okay, so I'll just comment it down so you can go back again and check it out. Okay, then we move on to priority queues. So priority queues are very important. Okay, so first of all, I'll take an integer type priority queue. So you can see that this is a max heap, right? This is a max heap declaration. So I'll push the elements. Okay, I'll push the elements in a random order. Let's say I push 100. Okay, then let's say I push 20. Then I push 1, then I push 500. Okay, and then let's say we push 3. Okay, now let's try to print it, how this priority queue will maintain the values. So write the dot top. Okay, and then pq dot pop. Okay, so as I said that this is a max heap, what will happen? Priority queue, this max heap will rearrange the element so that the top element is always the maximum one. Okay, so what will happen when we'll try to iterate over it? So it will first print 500, then it will print 100, then 20, then 3, and then 1. Okay, let's try it out. So we can see first 500, then we have 100, then we have 20, then we have 3, then we have 1. So every time we are getting the maximum element that is at the top of the priority queue, right? This is basically a max heap. Let's try to change this thing into a mini heap. What we'll do? Just we'll write vector int and we'll write greater int. Okay, and now your priority queue is ready for your mini heap is ready basically. Now you will see your elements would be like 1, 3, 20, 100, and 500. The order would be just reversed, right? Every time the minimum element would be at the top. So you can see 1, 3, then 20, then 100, then 500. And this is how basically priority queues works. We'll talk them about in detail when when we move on to the exact topic. अभी STL के बारे में बात करें, that's why we'll not go into detail. But when we cover this topic, we'll cover it in detail. Okay, so moving on, we'll go over to the final data structure, that is list. Okay, not return 0 भाई, return 0 नहीं करना था, return 0 रखना है. Okay, so we move on to list. So you just write list int, and you can write L or whatever you want. Okay, I generally prefer L for marking the name of the list. Okay, you can choose any variable name depending upon your question or depending upon the problem that you're facing. Okay, then we have like L dot push. Again, you can see we have push back and push front. As I said, that list is very similar in working to DQs. So you can see again we have two functions. We have push back, push front for back and front pushing. Then we will have pop back and pop front. Right. So I'll just write push back 1. Then we have a dot pushback 2. Then I write L dot push front 3, and then L dot push front 4. Okay. Now let's just try to iterate over this list L dot empty. So now, as I said, you can again, look at the back, you can look at the front. Let's say in this case, we look at the front element L dot front. So again, you can see L dot, as I write front, you can see we have front. If I write B, we have back, right? So we can use any of them. Back is basically telling us the last element, front is basically telling us the first element, right? I'll just write front, and I'll also write L dot back, okay, just to get the knack of it, okay. And this time, let's, pop it from the front, pop front, okay. Now let's try to run this piece of code. Yeah. So this time you can see that we pushed 3 4 at the front and 1 2 at the end. So basically when we are done with this process, our list would look like something like this. Okay, it would look like 4, then 3, then 2, then 1, and then 2. Okay, so basically your list would look something like this. Okay, 4 3 1 2. Now what do? We print the front element and the back element. So front element is currently 4 and back element is 2, so we can see 4 and 2 are printed, and then we pop from the front. So basically this time 4 will be removed, and it would look like this. Okay, then we have 3 1 2. Again we print 3 and 2, so we can see 3 and 2, we pop from the front, 3 is removed, we are left with 1 and 2. Okay, then we have 1 and 2, 1 and 2 is printed. Again we remove from the front, we are finally left with only a single element, that is 2. Now front and back both correspond to the same element, 2 and 2, and that's why 2 is printed. And then we pop from the front and our list becomes empty, it becomes like this. So that is basically how a list is implemented. You can try out other variants, you can try out with other data types, right? Whatever you want. Okay, it's completely your wish. Okay, and was all for part 2 of this part 2 of C++ STL. We haven't covered PBDS, that is basically policy based data structure, that we'll cover in next video or some other video. Okay, and this basically, these two parts basically cover all the data structures, all the containers that majorly you are going to use whenever you are going to learn DSA, or if you are going to do competitive programming. Generally only these containers you will use, not any outside of these. Okay, and that sums up our part 2, and we'll meet again with the next part 3, in which we'll be covering the algorithms, the inbuilt algorithm that C++ offers you through its STL. Okay, like reverse function, swap function, next permutation, sorted function, inbuilt sort function, okay, is sorted, previous permutation, and a lot of these things, right? Okay, we'll cover in the next video, part 3. Until then, bye bye guys, happy new year, enjoy your day, and may this year bring the happiest of your days. Okay, bye bye.